Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel Tanmoy Chem. Today's topic of discussion is one MCQ and the question is in front of you. What is the major product of this reaction? I suggest everyone to attempt this question in the comment box. It is an interesting question, so that's why I have selected this. Don't worry, don't hesitate whether your answer will be right or wrong. Remember, self-evaluation is essential for improvement. That's why you should try. So I believe we have tried, so let's start. So the question, what is the major product of this reaction? If you look at this is, by the way, alkene. It reacts with HBr, and what is the product? Remember, this is student actually an addition reaction. So in this case, I never suggest you that okay, alkene, unsymmetrical alkene, HBr is there, unsymmetrical reagent, so follow Markovnikov's rule. No, that will not give you the right answer. Let's go this problem stepwise. So this is actually unsymmetrical alkene, as I told. So here HBr addition. So this reaction is nothing but alkene addition with unsymmetrical reagent, that is HBr. So we know HBr, it's actually a very strong acid. Why? Because this hydrogen bromine bond is not strong. Why? Because hydrogen is small element, bromine is bigger element, improper overlap results weaker bond. Consequently, this H plus release is very easy, means it is a stronger acid. Now if you look at an alkene, there is a pi bond. So pi bonds are nothing but student electron rich. Why? Because pi electrons are loosely held by the two nucleus. So consequently, it's electron rich, as well as you can say there is lumpy electron density or loosely bound electron density. So that can react with H plus, which is electron deficient. Actually, there is no electron on H plus. So these H plus will react with this alkene, and whatever it will produce a carbocation. Now there are two options possible. One, you can say, sir, the carbocation will be here, secondary carbocation. So I mean the H plus attached here. And there could be another option, that is this CF3. By the way, practice drawing structure, it's very important. Now there is CH2 here, positive charge. Now there are two types of carbocation. Now question, which one will be more stable and why? Now apparently it looks like it's a secondary carbocation, so more stable compared to this one, primary carbocation. But actually the story is not that, because we know fluorine is a very high electronegative atom. Consequently, this CF bond is very polar, means fluorine pulls electron density from this carbon by is very strong minus I effect. Consequently, as a whole, this CF3 group shows very strong minus I effect. By the way, student, I have already discussed many lectures on this CF3 group. Please visit if you want to learn more. It's a very interesting. And if I say its electron withdrawing capability is just second to fluorine. So if you look at the minus I effect order, fluorine greater than CF3 greater than chlorine. So from there you can understand how much minus I effect this CH3 group has. Now if it has a minus I effect or withdrawing effect, means it will pull electron density. Now there is a positive charge. Positive charge means we say electron deficiency, and positive charge gets stabilized if there is electron donating group. But by the way, this CF3 as a whole, it is not at all electron donating group, it is electron withdrawing group. So in this case, although this carbocation is secondary, but its stabilization will be lesser compared to primary. Actually here there is a factor for destabilization electron withdrawing group, but in this case this electron withdrawing group is little away from this. In between there is a buffer zone, this carbon. So that's why it is relatively more stable, I'll say relatively more stable compared to the other one, secondary one. So that's why, since it is relatively more stable, it will be produced in more amount. And that's why in the next phase what will happen, the Br minus remaining, because first time H plus is consumed in the first step. So next step, Br minus will be attached here, and in this way it will result this bromo derivative as the major product. This carbocation is relatively more stable, so that's why it will result the major product. By the way, if you look at If you recall this Markovnikov's rule, what this rule said? This rule said negative part of the addendum will attach to that carbon which is poorer in hydrogen. So here this is poorer in hydrogen, one hydrogen attached to this carbon. But these will not be followed here because of the presence of this electron withdrawing CF3. So actually I haven't provided peroxide, but this product you may expect, sir, it looks like anti-Markovnikov product. So this is the actual speciality of this problem. By the way, if you take propene as a comparison, if I say, if you take this propene and do the same reaction under same reaction condition, HBr, what is the major product? In this case, Markovnikov's rule would have been followed. So remember, so these will be the major product. So this is the overall discussion about this. In this case, please follow the mechanism. That's why do not remember the tricks or do not learn the tricks blindly. Learn mechanism, it is needed. Now what is the major product of this reaction? Obviously this one, option B is the right answer. Now you may think, sir, if this question appear in your exam, how can I solve? So that thing you need to understand the nature of this CF3 group, very strong electron withdrawing group. So this is not possible, this is the product. By the way, if you think, sir, is it? Remember students, CF bond is very strong. I repeat, CF bond is very strong. It is very difficult to break. That's why you see polytetrafluoroethylene Teflon coating is there on the non-stick cookware, and we cook on this container. So that is one example that CF bond is very strong, very chemically inert. So breakage of CF bond, previously there was CF3, you have removed one hydrogen from here and here. So this CF bond breaking is an illogical option. So these are actually not a logical option. So I guess you understand why not this. So this is the overall discussion. I think you have learned a lot. If you really consider my contents and what did, then please hit the like button, subscribe this channel and share this video among your friends. See you in my next video. Bye bye.